we are going to discuss right angle triangle, right angle triangle, right angle triangle. So the entire session is of total 4 sessions. 4 sessions. The agenda of this entire session is to cover all the previous year questions, models, and the enhancement of these models. What if the question changes? What if instead of side height is given? Enhancement of models. The entire series only covers the previous year questions and the Anil Nair's way of solving the question. Totally we will discuss 90 plus questions from these PYQ series in 4 sessions, right? PYQ series, PYQ stands for previous year questions special series it is. 90 plus questions we will cover it up, and most importantly, right, we will discuss the concepts and we will discuss the application of the concepts, and we will also discuss, right, every possible question that came from CAT examination, Staff Selection Commission examination, CLAT examination, IPM examination, right, any other aptitude examinations where geometry is a part of it, I hope you are all with me. Let us immediately get into session number 1. This is a 4 session series. Session number 1. Right, now see here. Session number 1. First what we will do is, we will cover the important key points so that when we are applying it, I don't need to revisit any of the key points. Directly I will execute it. Important key points. Listen carefully, sir. Session number 1. Totally 4 to 5 sessions we will discuss. First thing, right angled triangle. A triangle is said to be a right angled triangle if one angle is 90 degrees. Let the angle that is 90 degrees, angle C. Angle C is 90 degrees. If I take angle B as a theta, sum of the 3 angles in a triangle is 180. So the remaining will be 90 minus theta. 90 minus theta. Now if you observe, this is theta, next it is 90 minus theta, and it is 90 degrees. So the side largest to 90 degrees is called the hypotenuse. C is called the hypotenuse. Hypotenuse is considered to be the largest side in a right angled triangle. Hypotenuse is considered to be a largest side in a right angled triangle. Now if you see here, theta 90 minus theta 90. One beautiful observation, 90 minus theta and 90. Suppose 90 degrees is the largest angle. The sum of the remaining 2 angles, it is equivalent to 90 degrees. That means if the sum of the two angles is equivalent to the largest third angle, if it is equivalent to largest third angle, then the triangle is called the right angled triangle. In a right angled triangle, there will be 3 angles. The largest angle is nothing but the 90 degrees. Side opposite to 90 degrees is nothing but the hypotenuse. If sum of 2 angles is equivalent to largest third angle, right, then the triangle is said to be a right angled triangle. There is a previous year question based upon this model. Angles are in the ratio. 3:4:7. Which type of triangle it is? One is 3x, another is 4x, largest is 7x. Sum of 2 angles equivalent to largest third angle, then the triangle is considered to be a right angle triangle. Each and every important key point I will discuss at the beginning, so that when we are solving problem, it will be easy for each one of us. Write down as an important key point. This is the first key point. I hope it is clear. Second key point in right angle triangle. A right angled triangle is a triangle in which one angle is 90 degrees. So these 90 degrees, I assumed that angle C is 90 degrees. This is B and it is A. Side opposite to small a, capital A is small a. Side opposite to capital B is small b. Side opposite to capital C is small c. So C is nothing but the hypotenuse. the hypotenuse. So c square, if I do the cosine rule, c square equivalent to a square plus b square minus 2ab cos angle c. Cos angle c is nothing but 90 degrees. Cos 90 is 0. C square equivalent to a square plus b square. C square equivalent to a square plus b square, where c is the largest side. Where c is the largest side. Where c is the largest side. That means if the largest side is hypotenuse, that means c square equivalent to a square plus b square. This we call it as an Pythagorean theorem. Pythagorean theorem. Pythagorean theorem. Pythagorean theorem suggests that hypotenuse whole square equivalent to s1 square plus s2 square, where s1 and s2 are the other two sides where the right angle is formed. S1 and s2 are the other two sides where the right angle it is formed. A right angle triangle is a triangle in which one angle is 90 degrees. Large side opposite to 90 degrees is c. C square equivalent to a square plus b square. Pythagorean theorem. Pythagorean theorem. Hypotenuse whole square equivalent to s1 square plus s2 square. S1 and s2 are the other two sides. I hope it is clear why you got c square equivalent to a square plus b square. Second point. Third point, Pythagorean triplets. Everything I am going to use it in the 4 sessions. Pythagorean triplets. Pythagorean triplets. Pythagorean triplets. What do you mean by a Pythagorean triplet? Now see here. Suppose if it is 90 degrees, this angle C is 90 degrees, this is A and it is B. These is nothing but small c, these is small a, these is small b. These is theta, these is 90 minus theta. Pythagorean theorem said that c square equivalent to a square plus b square. C square equivalent to a square plus b square. It is in variables. If I give some values to the variables, there will be some integral values which will satisfy the equation. So if c is of the form m square plus n square and a is of the form 2mn and b is of the form m square plus minus n square, we will get all the Pythagorean triplets. These are nothing but m square plus n square whole square equivalent to m square minus n square whole square plus 2mn whole square plus 2mn whole square. These are nothing but m square plus n square whole square is nothing but m square minus n square whole square plus 4m square m square. A minus b whole square plus 4ab is a plus b whole square. These are nothing but m square plus n square whole square equivalent to m square plus n square whole square. So it's very easy to determine if the hypotenuse should be of the form m square plus n square and one side should be of the form 2mn. If one side should be of the form 2mn, the other side is nothing but m square minus n square. What is that? We will see. What is that? We will see. What is that we have seen in a right angled triangle? In a right angled triangle, this should be 2mn and these nothing but m square minus n square and these nothing but m square plus n square. M square plus n square. The side should be greater than 0. So m square minus n square greater than 0. M square is greater than n square because m and n are positive. M is greater than n. M is greater than n. Now see here. If n is nothing but 1, I am starting with an integral value. M is greater than n. If I take m value 2. So these nothing but 2 into 2 into 1. 2 into 2 is nothing but 4. This will become 2 square minus 1 square. These nothing but 2 square plus 1 square. So what is the triplet that we got? 3, 4, 5. 3, 4, 5 is a Pythagorean triplet, right? I took the lowest integral value n equivalent to 1. M is greater than n. So what is the next integral value greater than 1? Which is nothing but 2. If n is nothing but 1, m is nothing but 3. These nothing but 2 3s are 6. Next it is nothing but 3 square minus 1 square. Are you all with me? 9 minus 1 is nothing but 8. So 3 square plus 1 square, it is nothing but 10. Are you all with me? You can derive innumerable number of triplets based upon this one. If n is 1, m is nothing but 4. D is nothing but 2 into 4, which is 18. 4 square minus 1 square, 16 minus 1, 15. 16 plus 1, it is nothing but 17. If m is nothing but 1, n is 1, m is nothing but 5. 5 square minus 1 square, 24. 5 square plus 1 square, right? 2mn, it is nothing but 10. Next it is nothing but 24. Next it is nothing but 24. 10, it is nothing but 24. Next it is nothing but 26. Sir, can I take n value 2? If n value is 2, m value if it is 3, 2 3s are 6, 6 2s are 12. Next it will be nothing but 9 minus 4, 5. 5, 12 and 13. Another triplet we got. Sir, can I take n value 5 and m value 6? Please take it out. 6 is 2 into 6 into 5. 2 6 are 12, 12 5s are 60. Next it is 36 minus 25, which is nothing but 11. 11, 60, 61. Depending upon the values of m and n, depending upon which values you take m and n, that Pythagorean triplet will be defined. Depending on the values of m and n, you will keep on getting various Pythagorean triplets. I just started with m, n1, m is 2, m is 3, m is 4, m is 5. Like that I have taken some Pythagorean triplets. I hope it is clear. Suppose if n is 20, m is greater than n, 21. So 20 square plus 21, right, which is nothing but 21, 20 and it is 29. We got another Pythagorean triplet. Like that, innumerable number of Pythagorean triplets can be determined by taking m and n values. I hope this point is very, very clear to you. This is how innumerable number of Pythagorean triplets can be generated. M is greater than n, n value 4, m value 6, n value 4, m value 8. Like that, anything can be determined. But a condensed version, the most high frequency Pythagorean triplets can also be done by using another concept that also we will discuss. I hope this concept is clear. Any Pythagorean triplet, hypotenuse is of the form m square plus n square and the sides are of the form m square minus n square and 2mn. m square minus n square and 2mn. Next point, Pythagorean triplets. All the 4 sessions, this introduction is extremely important. Otherwise, when you are solving problems, it will be little difficult for you. Pythagorean triplets. Case number 1. If the side is an odd number, take 3, square it and divide by 2. 9 by 2, 4.5. Subtract 0.5, add 0.5. You got 3, 4, 5, which is a Pythagorean triplet. 3 square by 2. Similarly, if I take the next odd number, 5 square by 2, which is nothing but 12.5. Subtract 0.5 and add 0.5, which is nothing but 5, 12 and 13. If I take 7 square by 2, 49 by 2, 24.5. Subtract 0.5 and add 0.5, 24 and 25. If it is 9 square by 2, 81 by 2, 40.5. Subtract 0.5 and add 0.5. So, all the Pythagorean triplets can be determined if the lowest side is an odd number. Another condensed version of finding the Pythagorean triplets. 7, 24, 25. 9, 40, 41. 11, 60, 61. And so on, and so on. I hope it is clear. If the side is an odd number, square it and divide by 2. Do plus or minus 0.5. Square it and divide by 2. Do plus or minus 0.5. Do plus or minus 0.5. You will get all the Pythagorean triplets where the lowest side is an odd number. Case number 2. Case number 2. Case number 2. Side is an even number. if the side is an even number, the is 4. Square it and divide by 4 because 2k, any even number is of the form 2k. 2k square is divisible by 4. The is 4. Subtract 1 and add 1. 3, 4 and 5. Suppose if it is 6. Square it and divide by 4. 36 by 4, 9. Subtract 1 and add 1. Another triplet is 6, 8 and 10. Suppose if it is 8. Square it and divide by 4. 16. Subtract 1 and add 1, which is nothing but 8, 15 and 17. Suppose if it is 10. Square and divide by 4. 100 by 4, 25. Subtract 1 and add 1, which is nothing but 10, 24 and 26. 10, 24 and 26. Case number 1, side is an odd number. Case number 2, side is an even number. Side is an odd number and side is an even number. Now you can determine all the possible important triplets when the lowest side is an odd number, except this case. For 4, we have to take an even number greater than 4 for it to become a lowest side. So these are the high frequency Pythagorean triplets, which we will write in the next point. The most high frequency Pythagorean triplets. High frequency Pythagorean triplets. High frequency Pythagorean triplets. These are the triplets which are coming most repeatedly in your examination. One is 3, 4, 5, and another is 5, 12, 13, and another is 7, 24, 25, another is 9, 40, 41, 9, 40, 41, 11, 60, 61, 8, 15, 17. These 6 Pythagorean triplets are the most highly repeated Pythagorean triplets into K. K could be any number, any real number. K could be any real number. Suppose if you see 3, 4, 5 into 2, 6, 8, 10 is a derived triplet of 3, 4, 5. 3, 4, 5 into 3. 9, 12, 15 is a derived triplet of 3, 4, 5. 5, 12, 13 into 2. 10, 24, 26 is a derived triplet. Whatever I am writing here, these are nothing but the derived ones. Whatever I am writing to the left side, these are nothing but the basic ones. What is the difference between basic Pythagorean triplet and derived Pythagorean triplet? In a basic Pythagorean triplet, HCF of all the numbers will be 1. HCF of all the numbers will be 1. Or in other words, A, B, C are co-prime to each other. A, B, C are co-prime to each other. In the derived ones, they are not co-prime to each other. They are not. Why they will be co-prime to each other? When you are multiplying with some real number, obviously that all the numbers will be a multiple of the number. If all the numbers are a multiples of 1, then only the numbers are said to be co-prime. Otherwise, they are said to be not co-prime. I hope it is clear. These are the high frequency Pythagorean triplets. 3, 4, 5. 5, 12, 13, 7, 24, 25, 9, 40, 41, 11, 60, 61, 8, 15, 17, 8, 15, 17. I hope it is clear. Now we will write some important points, some important key points which is of extreme use to us when we are solving the problem. Important key points. Now see here. First important key point. If it is a right angled triangle, ABC. If I draw a circle that touches the vertices of a triangle, that is nothing but the circumcircle, and the radius of the circumcircle is called the circumradius. Radius of the circumcircle is called the circumradius. Circumradius is nothing but half of hypotenuse. In a right angled triangle, circumradius is always nothing but half of the hypotenuse. Circumradius is nothing but half of hypotenuse. Good number of questions are asked from this point. So that means circumradius, this is the radius of the circle, this is also the radius of the circle, this is also the radius of the circle. Circumradius is also nothing but median. Circumradius is also nothing but median. Please make a note of it. R is nothing but h by 2. R is nothing but the median. M is the median. H is the hypotenuse. h is the hypotenuse. Why circumradius it is the median? Why? Because if I draw a line right from the midpoint, this is the radius, this is the radius, that means this is the midpoint. The line joining the midpoint of a side to an opposite vertex, that is called the median. Therefore BD is nothing but the median. The circle that is touching the vertices of a triangle, that circle that is touching the vertices of a triangle is called the circumcircle. First important key point, when we are solving the question, directly we will execute this point. Circumradius is always given as half of the hypotenuse and is also called the median, and it is also called the median, Second point, suppose if I take a right angled triangle A, C and B, if I draw a circle touching all the sides of a triangle, the circle which touches all the sides of a triangle, is called the incircle. It is called the incircle. This is called the incircle, and the radius of that incircle is called the inradius. Radius of the incircle is called the inradius. This is nothing but the inradius. This is nothing but the inradius. This is nothing but the inradius. I hope it is clear. This inradius is given by, if this is, I already proved it to my previous classes for the enrolled students, so I will not waste any time. Inradius is always given by, inradius in a right angled triangle, it is always given by semi-perimeter minus hypotenuse. Inradius is always given by semi-perimeter minus hypotenuse. Semi-perimeter is nothing but a plus b plus c by 2. Right? Semi-perimeter is a plus b plus c by 2. Total perimeter is nothing but the distance from a source traveling along the boundaries of a line and coming back to the source. SC is nothing but a plus b plus c by 2. Inradius is nothing but semi-perimeter minus hypotenuse. This is nothing but S minus H. It is nothing but S minus H. In the case of a right angled triangle, already we have seen R is nothing but half into H. R median is nothing but half into H. So inradius is nothing but semi-perimeter minus 2R. Right? Inradius is nothing but semi-perimeter minus 2 into median. I hope the idea it is clear. Inradius is nothing but semi-perimeter minus 2R, semi-perimeter minus 2M. Extremely important key point, sir. Inradius is given by semi-perimeter minus hypotenuse. It is also semi-perimeter is a plus b plus c by 2 minus c. It is a plus b minus c by 2. A plus b minus c by 2. Inradius is semi-perimeter minus hypotenuse. Hypotenuse is 2 times the circumradius. Hypotenuse is 2 times the median. Inradius is S minus 2R or S minus 2M. Listen carefully, sir. From this point, I can deduce some important key point in the third one. Third key point. Inradius is nothing but semi-perimeter minus hypotenuse. Inradius is semi-perimeter minus hypotenuse. So, this is nothing but circumradius is half of the hypotenuse and it is also nothing but the median. So, inradius is semi-perimeter minus 2R. R is nothing but S minus 2R. R plus 2R. It is nothing but S. Semi-perimeter in terms of inradius and circumradius is given by R plus 2R. We know that delta is nothing but R into S. We know that delta is nothing but R into S. R into S. What is R? R is nothing but inradius. R is nothing but inradius. S is nothing but the semi-perimeter. S is nothing but the semi-perimeter. So delta is nothing but R into R plus 2R. Extremely important concept, sir. If in radius, if R is the in radius, if the in radius and circumradius are given, if in radius and circumradius are given, then the area of a triangle is given by R into R plus 2R. Then in radius and circumradius are given, area of a triangle is given by R into R plus 2R. R into R plus 2R. Another important key point, hypotenuse is nothing but 2 into M. So if semi-perimeter and medians are given, in radius is also given by semi-perimeter minus 2 into median. It all depends upon the question what values are given. If in radius and circumradius is given, semi-perimeter can be determined by R plus 2R. If area of a triangle is given, area of any triangle in terms of in radius and semi-perimeter is R into S. So delta equivalent to R into R plus 2R. In terms of median, it is SP minus 2 into M. Fourth key point. Every concept I am going to solve it in the previous year question problem. These are nothing but the in radius. These are nothing but the in radius. This is R. This is R. These also are. Now if you see, these are nothing but, it is C. These are nothing but A. These are nothing but B. These are nothing but C. These are nothing but small a. These are nothing but small b. These are nothing but 2R. These are nothing but 2R. Now if you see, from here to here, this is R. If this is R, from here to here, this is R, but B is greater than 2R. B is greater than 2R. B is greater than 2R. That means C is equivalent to hypotenuse is nothing but 2 into circumradius. Hypotenuse is nothing but 2 into circumradius, and the other two sides, it should always be, it should always be greater than 2 into in radius. Please write down. A side of a right angled triangle, it is always greater than 2 into another radius. Anyway, hypotenuse will be greater than other two sides. So hypotenuse is greater than S1, S2. So S1 and S2, it is always greater than 2 into in radius. Any two sides, it is always greater than 2 into in radius. Hypotenuse is always greater than 2 into in radius. This helps us in eliminating the answer options. This helps us in eliminating the answer option. When a question comes, I will discuss in radius, circumradius. Another important key point, fifth key point, in a right angled triangle. These I already proved it, so I will not prove it again. Enrolled students, we have already proved it. So this I am taking angle C as 90 degrees. So let us use the standard framework. This is C and it is B. Now if you see here, from C to D, if I drop a perpendicular, from C to D, if I drop a perpendicular, these are nothing but A, these are nothing but B, these are nothing but B. Now listen carefully, sir. These are nothing but B. Now if you see here, these are nothing but small c. These are nothing but small c. So we have already discussed in our no similarity in right angle triangle class. P is nothing but AB by C. P, it is nothing but AB by C. P is nothing but AB by C. I hope it is clear. P is nothing but AB by C. Now listen carefully. Why it is P? Half into base into height. Half into P into C is half into A into B. So P is nothing but AB by C. Very, very important point. Another point based on right angles, we have already seen it. These are nothing but 90 degrees. These are nothing but 90 degrees. AD value, it is given by B square by C, which we proved it in our previous class. AD is nothing but B square by C and C is nothing but A square by C. A square by C. Please make an important note of it, sir. AD is B square by C and B is A square by C. That means if a right angled triangle is there like this and it is 6 and this is 8 and this is 8. If it is 8, now if you see here, these is nothing but 10 because based on Pythagorean triplets, these is nothing but 8 square by 10, 6.4. These is nothing but 3.6. These is nothing but 3.6. I hope the idea it is clear. I hope the idea it is clear. P equivalent to AB by C. Another important key point. See here, sixth one. Suppose if I take a right angled triangle, these are nothing but P, these are nothing but ACB, these are nothing but A, these are nothing but C, these are nothing but small c. What is that we discussed right now? P is nothing but AB by C. P is nothing but AB by C. 1 by P is nothing but C by AB. 1 by P square, it is nothing but C square by A square B square. 1 by P square, it is nothing but A square plus B square divided by A square B square. It is nothing but 1 by P square equivalent to 1 by A square plus 1 by B square. Very, very important learning. Please make a note of it. 1 by P square equivalent to 1 by A square. 1 by A square plus B square. 1 by A square plus 1 by B square. I hope the idea it is clear. In the previous, I think, vertex maybe I have taken incorrect. This is C and it is D. This is small a and it is small b and it is small c. AD is nothing but B square by C. BD is nothing but C square by A. Please make a note of it. Very, very important key point. 1 by P square equivalent to 1 by A square plus 1 by B square. 1 by P square equivalent to 1 by A square plus B square. Very easy proof. P is AB by C, reciprocal is C by AB. So, because of it is a Pythagorean triplet, C square equivalent to A square plus B square. C square equivalent to A square plus B square. I hope the idea it is clear. Write C square equivalent to A square plus B square. This is an important key point. Seventh key point. All the key points I am discussing at the beginning so that it will be easy for you when we are solving the problem. ACB. These is nothing but small a and these is nothing but small c and it is nothing but small b. These is nothing but, if I call it as D, CD square is nothing but AD into DB. CD square is nothing but AD into DB. These is nothing but CD into CD equivalent to AD into DB. These is nothing but CD by AD. CD by AD is equivalent to DB by CD. CD by AD equivalent to DB by CD. From where you got these? CD square equivalent to AD into DB. These is nothing but 90 degrees. These is theta. These is nothing but 90 minus theta. These is nothing but 90. These is nothing but 90 minus theta. These is nothing but theta. And these is nothing but 90. Now see here. CD by AD. CD by AD. Now if you see here, if I take this triangle ADC, what is 90 minus theta? Opposite 90 minus theta opposite is CD. Here what is opposite here? 90 minus theta opposite BD. I hope it is clear. CD by BD. What is 90 opposite in this triangle? Which is nothing but AC. What is 90 opposite in this triangle? Which is nothing but BC. What is theta opposite in this triangle? Which is AD. What is theta opposite in this triangle? CD. So these, if I take first with last, CD whole square equivalent to AD into BD. I hope this point is very clear. From this also previous year examination questions are asked. Point number 7. I hope it is clear. So the CD square is nothing but AD into BD. AD into BD. Another important key points. Please write down. Eighth one. In the case of a right angled triangle, in case of a right angled triangle, in case of a right angled triangle, in case of a right angled triangle, orthocenter lies exactly at the point, where the 90 degrees is formed, lies at the point where 90 degrees is formed, or it lies at the point, right? What is orthocenter? Orthocenter is the point of intersection of altitudes. Altitude is nothing but which makes angle 90 degrees. So in this triangle ABC, the orthocenter lies at the point center. Orthocenter lies at the point B. Orthocenter lies at the point B. This is the first point. Second point, suppose if I take a circumcircle, right? Circumcenter lies on the hypotenuse. 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 First point and second point, it is clear. Orthocenter is the point of intersection of 90 degrees. Circumcenter is nothing but the point of intersection of perpendicular bisectors. Point of intersection of perpendicular bisectors. First and second point, I hope it will touch the vertices, sir. It will touch the vertices. Orthocenter and circumcenter. Orthocenter and circumcenter. Next point, in a right angled triangle, avoid using Apollonius theorem to determine the, please write down, sir. Avoid using Apollonius theorem to determine the length of the median. Avoid using Apollonius theorem to determine the length of the median. Avoid using Apollonius theorem to determine the length of the median. Length of the median, it is nothing but half of the hypotenuse. It is nothing but half of the hypotenuse. Next, see here, last key point before we get into an problem solving key point. Listen carefully. Key point. Suppose a circle is inscribed in a square. A circle is inscribed in a square. This is the case where the circle is inscribed in a square. If the circle is inscribed in a square, this is nothing but the diameter. This is also nothing but the side of the square. First write down diameter of the square. Diameter of the square. It is nothing but the diameter of the circle. Diameter of the circle is nothing but the side of the square. Please make a note of it. If a circle is inscribed, in a square, diameter of a circle is nothing but the side of the square. Very, very important. Diameter of the circle is nothing but equivalent to side of the square. This is the first key point. Or if the square is inscribed in a circle, this is the circle and a square is inscribed in a circle. If a square is inscribed in a circle, this is the case where square is inscribed in a circle. If a square is inscribed in a circle, listen carefully, sir. If a square is inscribed, this is nothing but the diameter of a circle. Diameter of a circle. Diameter of a circle. It is equivalent to diagonal of a square. It is equivalent to diagonal of a square. It is equivalent to diagonal of a square. This is the case where square is inscribed in a circle. Previous case is circle is inscribed in a square. All the important key points with respect to right angled triangle, we did it. Now we will solve some good problems based upon this right angled triangle. First, we will take some warm-up questions. Problems. First one, there is a square. A circle is inscribed in that square. To one side of the square, there is a rectangle. Find the radius of the circle. There is a circle that is inscribed in a square. ABCD is a square. Some warm-up questions. ABCD is a square. A circle is inscribed in that one. Right to one side of the square, there is a rectangle that is inscribed. Find the radius of the circle. Now listen carefully. How to solve this question? This is the center of the circle. This is the center of the circle. This is nothing but the radius. This is nothing but the radius. Tangent always makes an angle of 90 degrees with the radius. This is also the radius. This is also the radius. This is also the radius. So from a center to a point on the circumference, it is always the radius. Now see here. From this point, drop a perpendiculars. Drop perpendiculars. If I drop a perpendicular, from here to here it is R. From here to here it is R. Now these is nothing but total from here to here it is R. But from here to here it is 20. So this will become R minus 20. Are you all with me? Join these points. From here to here it is R minus 20. Why? Because from here to here it is R. From here to here it is 20. So from here to here it is R minus 20. Similarly, from here to here it is R. But this is 30. So these is nothing but R minus 30. These is nothing but center to circumference it is R. Anyway, I dropped a perpendicular. So these is 90 degrees. So it is nothing but R square equivalent to R minus 20 square plus R minus 30 square. R square equivalent to R minus 20 square plus R minus 30 square. Solve the equation, you will get the value of R. Solve the equation, you will get the value of R. Second time I am explaining so that it will be extremely clear to you. Write some good warm-up questions, then we will get into previous year question. Now see here, this is the question. Now those students who have not understood it, listen carefully. This is the center. From center to circumference it is R. These also R. These also R. Drop a perpendicular. From here to here it is R. From here to here it is 30. So it is R minus 30. From here to here it is R. Top it is 20. So it is nothing but R minus 20. R square equivalent to R minus 20 square plus R minus 30 square. So R value, if you get a negative value, radius cannot take a negative. That itself is the answer. I hope the first one it is clear. Second one, right? Now see here, second question. There is an x-axis and the y-axis. There is x-axis and y-axis. There is a circle which is touching the axis. The circle is not drawn to the scale. There is another chota circle that is present here. There is present here. This, it is given in the question. The center of bigger circle is C2. Center of smaller circle is C1. O C1 C2. O C1 C2. They are all collinear. They are all collinear. Collinear means they all lie on the same line. They all lie on the same line. They all lie on the same line. Right? If the radius of bigger circle, if the radius of bigger circle is 4 units, find the radius of smaller circle. Find the radius of smaller circle. Radius of bigger circle is 4 units, find the radius of smaller circle. O C1 C2, it is given as, right, collinear. Collinear means they all lie on the same line. They all lie on the same line. Now see here. Because they all lie on the same line, draw a line joining all these points. Draw a line joining all these points. Draw a line joining the circumference. These nothing but R. These nothing but R. These also nothing but R. So OC2 will become root 2R. Root 2R. I hope it is clear. If it is R, this also will become R. This also will become R. R and R, these root 2R. Now see here. From here to here, it is also R. Now, listen carefully to these points. Listen carefully. These small. These are nothing but R. These are nothing but R. So, this will become root 2R. Are you all with me? This will become root 2R. So, that means OC2 root 2R is nothing but, from here to here, it is nothing but R. From here to here, it is nothing but R. From here to here, it is nothing but root 2R. R into root 2 minus 1 equivalent to r into root 2 plus 1. So r by r is nothing but root 2 plus 1 divided by root 2 minus 1. Root 2 plus 1 divided by root 2 plus 1. Some students in hurry, they might solve it as r plus 2r, which is mistaken. There is some leftover gap here. There is some gap here. This gap you need to consider. This gap you need to consider. Again I am explaining. OC1, C2 are collinear. Collinear means draw a line. If this is R, these are. OC2 will become root 2R. OC2 will become root 2R. First step clear, right? So these nothing but, how you got this equation? OC2 is nothing but from here to here, it is R. From here to here, it is small r. From here to here, r, and the remaining it is nothing but root 2r. So radius of the bigger circle. So answer is 4 into root 2 minus 1. 4 into root 2 minus 1. 4 into root 2 minus 1 divided by root 2 plus 1. This is nothing but capital R. This is nothing but capital R. To all the enrolled students, next week completely close to 200 plus questions only on circles I am solving it. Next week completely dedicated to triangles and similarity of the triangles. Triangles and similarity of the triangles. I hope this idea is clear. Second point. Third one, we can also develop a question based on what we observed, right, in the previous question. This is nothing but circle, right? This is nothing but a circle. Now if you see here, this is nothing but circle. If this is radius, this is nothing but radius. This is nothing but radius. This is nothing but, if I join it, right, assume center and the coordinate origin, it is nothing but, right, they are collinear. Oh, so this is nothing but root 2r is nothing but r plus. This is nothing but r plus this gap. So the gap value can also be determined. This gap value, this is nothing but root 2r minus r, which is nothing but r into root 2 minus 1. R into root 2 minus 1. I hope this third question observation, it is also clear. If this is R and it is R, it is given in the question that O comma C1 are collinear. O comma C1, they are all collinear to each other. R and R. OC1 is nothing but root 2R. Root 2R is equivalent to R plus this gap. OC1 is nothing but OA plus AC1. OA plus AC1. We want OA. OA is nothing but the gap. OA is nothing but the gap. Third question, I hope it is clear. Fourth question. Fourth one. There is a rectangle. There is a rectangle. There is a rectangle. Now see here. There is a rectangle. In that one, two circles are inscribed like this. This is one circle and it is another circle. Two circles are inscribed like this. This is nothing but, the length of the rectangle is 30 and this is nothing but 40. This is nothing but 40. Radius of two circles are same. Radius of two circles are same. If the radius of two circles are same and they are inscribed in a rectangle, find the radius of two circles. Find the radius of two circles. Find the radius of two circles, right? Let me call this point as A, B, C, D. A, B, C, D. This is C1, this is C2. Nothing is given about, if you draw a line joining the centers, that will definitely pass through the vertex of the squares. It is not given. It may or may not be. BC1, C2, comma D may or may not be collinear. May or may not be collinear. They may or may not be collinear. So just don't do this mistake of drawing like this and solving it. That is a mistake which is not given in the question. If it is not given in the question, you will not take it, that value. I hope it is clear. Two circles are inscribed in a rectangle with length 30 and breadth 40. B, C1, C2, D may or may not be collinear. Radius of two circles. Listen carefully, sir. Radius of two circles. C1, C2, join it. If I join it, if it is R, this will also be R. R and R. From here drop a perpendicular. From here drop a perpendicular. It may touch the circumference, it may be above, it may be below, because the circles are not drawn to the scale, right? So it may be any part. Now see here, these are nothing but R. These are nothing but R. Now listen carefully. See here, this is R. This is R. Total is nothing but 30. This side R. This side R. From here to here, it is nothing but 30 minus 2R. Are you all with me? This is 30 minus 2R. From here to here, R. From here to here, R. This down is nothing but R. Top is nothing but R. Total is nothing but 40. These nothing but 40 minus 2R. So finally I got a right angled triangle. Finally I got a right angled triangle like this. Finally I got a right angled triangle like this. So what is the equation? R plus R is nothing but 2R. 2R whole square equivalent to 30 minus 2R square. 30 minus 2R square plus 40 minus 2R square. 2R whole square equivalent to 30 minus 2R square plus 40 minus 2R square. I hope the idea it is clear. These are nothing but R. These are nothing but R. Left side R, right side R. These is nothing but 30 minus 2R. Top is R, bottom is R. This value is nothing but 40 minus 2R. So this is nothing but a perpendicular. So 2R will become hypotenuse. 2R whole square equivalent to 30 minus 2R square plus 40 minus 2R square. From here you will get the value of R. From here you will get the value of R. The first 4 questions, I hope it has given you a good understanding of how to find out the value of a radius of a circle if they are inscribed in a rectangle. In a rectangle, the best thing is if you draw the diagonals. Suppose if it is given, this is nothing but an ABCD. ABCD. If this is given 13, if this is given, this is 13, this is 5. Immediately in a rectangle, one angle is 90 degrees. So immediately you can say it is 12. In a rectangle, opposite sides are equal. So area it is nothing but 5 into 12. It is nothing but 60. These Pythagorean triplets are extremely important to you. These given as 15, and it is said that the perimeter of a right angled triangle, it is nothing but, it is given as 36. So immediately it should strike you 3, 4, 5 is a Pythagorean triplet. Hypotenuse is 15. So if I multiply by 3, it is 9, 12, 15. One case is 9, 12, 15 if the sides are integers. Check it out whether it is satisfying the question. Perimeter is nothing but 36. 9 plus 12, 21 plus 15, 36. It is satisfying. So other two sides are 9 and 12. And the area is nothing but half into 9 into 12. So answer is nothing but 54. You have to be extremely good in using Pythagorean triplets to find out the values. That is exactly the reason I discussed Pythagorean triplets. That is exactly the reason I discussed Pythagorean triplets. By knowing that Pythagorean triplets, your problem becomes much more easier. Now let us solve few questions. Now we know that the directions are, these are nothing but the east direction, these are nothing but the west direction, these are nothing but the north direction, these are nothing but the south direction. South is when a person is traveling right bottomwards. North is when a person is traveling topwards. West is when a person is traveling leftwards. East is when a person is traveling rightwards. I hope it is clear. Suppose if a person is standing like this, these to the left, right, these to the left, anything to the top of the head, these east, these west, these north, and it is south. Now first question, a ship after sailing 12 kilometers towards south, 12 kilometers south is bottom, it is going from a particular place. After going, it travels 5 kilometers towards east, 5 kilometers towards east, these 90 degrees, 5 and 12. So distance is nothing but Pythagorean triplet, it is nothing but 13. First one answer is 13, just an understanding of directions. I hope it is clear. If the sides of a triangle are in the ratio 3 is to 1, 1 by 4 is nothing but 5 by 4. 3, 1 by 4 is nothing but 13 by 4. Multiply by 4, it is nothing but 12, 5 and 13. So 5 is to 12 is to 13. These are nothing but the sides of a triangle, and it is forming a Pythagorean triplet. 5 square plus 12 square is 13 square. So it is a right angled triangle. It is a right angled triangle. I hope it is clear. It is a right angled triangle. Next one. It is third question. The length of the tangent drawn to a circle. Tangent always makes an angle of 90 degrees. These is nothing but 4 units. These is nothing but 90, right? And this tangent is 5 meters away from the center of a circle. 5 centimeters away. So these 5, these 4. This point is nothing but 3 centimeters. Easy question, direct application. All these questions came in SSC, CHSL, right, and other examinations. 3 centimeters. There is a circle there. There is a point outside the circle. A tangent is a line which touches the circle exactly at one point. Tangent always makes an angle of 90 degrees with the radius. So these 4. The tangent is 5 units away from the center of the circle. 4 and 5. This value is nothing but 3. I hope the idea it is clear. Basic application. If the sides of a right angled triangle are 3 consecutive integers, you can do it in any ways. These is nothing but x plus 1. These is nothing but x minus 1, and it is nothing but x. Consecutive integers differs by 1 unit. Either you can apply the Pythagorean values, which I don't suggest you to use it. X square plus x minus 1 square. These is nothing but, so x plus 1 whole square minus of x minus 1 whole square, it is nothing but x square. 4x is nothing but x square. X cannot be 0, so x is 4. So these is nothing but 4, 3, 5. 4, 3, 5. 4, 3, 5. The length of the smallest side, it is nothing but 3. Or if you are good in Pythagorean triplets, 3, 4, 5 satisfies this condition. Directly you can say that the answer is 3. I hope it is clear. Length of the 3 sides of a right angled triangle are x minus 2, x plus 2. X plus 2 is the largest side. X plus 2 is the largest side. So these x plus 2, these x minus 2, and it is x. So what you can do is, what is the Pythagorean triplet with these nothing but x minus 2, x and x plus 2. Difference is nothing but 2 units. If the difference is nothing but 2 units, right, if these, when the difference is 1, but I want the difference 2 units, so into 2, answer is nothing but 6, 8, 10. 6, 8, 10. So x value is nothing but 8. 8, 6, and it is nothing but 10. 8, 6 and nothing but 10. I hope the idea is nothing but clear. 3, 4, 5. Difference is nothing but 1. But I want difference 2. So multiply by 2. Multiply, it is nothing but 2. Now, otherwise, if you want to use these equation, which you should definitely not use in your examination, x minus 2 square plus x square. These is nothing but 8x is nothing but x square. X is nothing but 8. X is nothing but 8. Now, what is important here is this observation. This is a very important observation. Please make a note of it, sir. Suppose in a triangle with Pythagorean triplets 3, 4, 5. It is 3, 4, 5. In radius is nothing but a plus b minus c by 2, which is nothing but 1. circumradius is nothing but half of the hypotenuse. R is nothing but 2.5. So in 3, 4, 5, in radius is 1, circumradius is 2.5. Sir, see here, sir. See here. Suppose, see here, 3, 4, 5. This is very, very important for us to solve the problem. In radius, right, circumradius, hypotenuse, and the area of a triangle. All these values we will do. In radius, circumradius, hypotenuse, and the area of a triangle. These are nothing but 1. Circumradius is nothing but 2.5. Hypotenuse is nothing but 2.5 into 2, it is 5. Right? These are nothing but half into 3 into 4, which is nothing but 6. Now what is important is, what is the area of a triangle? What is the area of a triangle? If an in radius is 4, only in radius is given as 4. If the in radius is 4, these multiplied by 4 times. These are nothing but 12, 16 and 20. It is multiplied by 4. 3, 4, 5 multiplied by 4. 12, 16, 20. So area is nothing but half into 12 into 16, which is nothing but 96. It is nothing but 96. Directly you will come to know. Directly it is nothing but, it is multiplied by 4. In radius also is half of the hypotenuse, which is 10. I hope it is clear. Suppose if the in radius is given as 6, if the in radius is given as 6 in a right angle triangle, 1 is becoming 6, multiply by 6, 3 6 are 18, 4 6 are 24, 5 6 are 30, 1 is multiplied by 6, 2.5 is multiplied by 6, 15. Hypotenuse is 2 times the circumradius, which is 30. Half of 18 into 24. Answer is nothing but 216. Answer is nothing but 216. I hope the idea is clear. If in radius is nothing but 2.5, if the in radius is 2.5, 1 is becoming 2.5, these are nothing but 7.5, these are nothing but 10, and it is nothing but 12.5. So 1 became 2.5 multiplied by 2.5, these are nothing but in radius is nothing but 2 into 2.5, which is 6.25. Hypotenuse is 2 times the circumradius, which is 12.5. I hope the idea is clear. Only thing what you need to know is this strip. Once you know this strip, then remaining all are multiplication factors. 3, 4, 5, right? In radius become 4 times, sides also become 4 times, radius also becomes 4 times, hypotenuse is 2 times the radius, right? I hope it is clear. If in radius is 4 times, if you observe, area of a circle, it is nothing but pi r square. It is pi r square. So if it is 4 times, this became 4 square 16 times. If it is 6 times, this became 36 times. Area of a circle is pi r square. So if the radius is getting multiplied by 4, area will get multiplied by square of the radius. Area will become square of the radius. Very important. I am going to take some problems based upon this one. Take some problems based upon this one. I hope it is clear. So value substitution is an extremely important method in geometry. I hope this idea it is clear. If the length of the 3 sides of a triangle are 6, 8 and 10, 6, 8, 10 is nothing but an right angled triangle. In a right angled triangle, median is nothing but a circumradius, which is nothing but half of hypotenuse. Answer is nothing but 5. Answer is nothing but 5. So median it is nothing but, right, circumradius, which is half of the hypotenuse. This cannot be the answer. Why? Because hypotenuse is nothing but 2 into m. When I said that hypotenuse is 10, 8 into 2 is 16. These also cannot be. This cannot be less than. I hope it is clear. I hope the idea it is clear. Next one. All are based on right angle triangles, sir. ABC is a right angled triangle. ABC is a right angled triangle. AB and C, these 90 degrees. These are nothing but 6. These are nothing but 8. A circle has been inscribed. If it is inscribed, I will get in radius. I will get in radius. In radius is, if it is 6 and 8, these are nothing but 10. In radius is semi-perimeter minus hypotenuse. Semi-perimeter minus hypotenuse. This is 6 plus 8 minus 10 by 2. R is nothing but 2. R is nothing but 2. R is nothing but 2. Now, listen carefully here, sir. R is nothing but 2. What is that? I said side is always greater than. Side is always greater than 2 into in radius. I hope, right, you remember this point. Side is always greater than 2 into in radius. So, if it is 6, third option, right, if it is 3, side is greater than, 6 is greater than 6, not possible. Fourth option, 6 is greater than, it is not possible. So, just by looking at a question, because you know this concept, you can eliminate 3 and 4. This concept helps us in eliminating incorrect answer options. This concept helps us in eliminating incorrect answer options. These options helps us in eliminating incorrect answer options. Idea it is clear. So 3 and 4 can be eliminated because of this concept. Side is greater than 2 into R. Next one. Now see here. Now listen. What is the area of the circumcircle of a triangle with sides 6, 8 and 10? If it is 6, 8 and 10, these 6 and it is 8 and it is 10. Area of a circumcircle. Area of a circumcircle is nothing but pi r square. So these nothing but 22 by 7. Circumradius is half of the hypotenuse. Half into h. It is nothing but 5. 22 into 5 square. 22 into 5 square. Now listen carefully, sir. Now listen carefully. It is nothing but 22 into 25 divided by 7. 22 into 25 divided by 7. One way it is to multiply. These are nothing but 550 divided by 7. 550 divided by 7. Another way to do it, it is, now see here, 550 divided by 7. 550 divided by 7. 22. 22, it is a multiple of 11. It's a multiple of 11. All the options are multiple of 11. Very good. 7 minus 7. 5 minus 5. 2 minus 2. Right. It is right. All the options. So otherwise I would have checked with whether the answer is a multiple of 11 in the numerator. I hope it is clear. Or otherwise what you can do is you can use the digital sum concept. 22 digital sum is 4. 25 digital sum is 7. 4 7s are 28. 28 digital sum is 10, which is 1. 22 it is 4. 25 7. 4 7s are 28. 2 plus 8 it is 10. It is nothing but 1. Numerator digital sum should be 1. Numerator digital sum should be 1. 1100 it is not possible. Digital sum is 2. These also not possible. These 2 plus 7 9, 9 plus 5 14, not possible. In case if you want to avoid it, 22 into 25 it is simple. Suppose if example, if the radius is 17 units, this concept will be immensely helpful. I hope it is clear. This calculation might take little more time. Use the digital sum concept in the numerator. Use the digital sum concept in the numerator. ABC is a right-angled triangle. ABC is a right-angled triangle. These are nothing but 6, these are nothing but 8, these are nothing but 10. Radius of incircle. Radius of incircle. In radius is nothing but semi-perimeter minus hypotenuse by 2. 14 minus 10. 4 by 2 it is 2. So these are nothing but 20, okay, radius only it is given as 2. So answer is nothing but 2. Now see here, sir, what is that we discussed? Side should be greater than 2 into in radius. Side should be greater than 2 into in radius. In fact, all the sides should be greater than 2 into in radius. If I take this point, side is greater than 2 into 4, 8. 6 is not greater than 8. So if 4 is not possible, 6 also it is not possible. 6 is greater than 12, not possible. Right? 3, side should be greater than, 6 is greater than 2, 6. It is also not possible. Answer is 2. In case even if you forget R is semi-perimeter minus hypotenuse, still you can eliminate answer options based upon this concept. All the sides of a right-angled triangle should be greater than 2 into in radius. First one 4, side is greater than 8, 6 is not greater than 8. Third one 6, 4 is not possible, any value greater than 4 not possible. 3, side is greater than 6, 1 6 is right, 6 is not greater than 6. So option is 2. You can also use that concept. That's exactly the reason why I discussed this concept. Now see here, it is 90 degrees, this is 6, this is 8, this is nothing but 10. Now if you see here, this is nothing but circumradius it is nothing but 5 units, circumradius it is nothing but 5 units, right? So answer is nothing but 5. If you draw the circle, let us draw the circle. If I draw the circle, this is the center, this is the center, and this is nothing but the height. This is nothing but the height. I hope it is clear. Now if you see here, this is nothing but the height, and this angle is 90 degrees. This angle is 90 degrees. This is a right angled triangle. This is a right angled triangle. Now see here, if it is 3 and 4, 3 and 4, if it is, this is the height. Height is nothing but 3 into 4 by 5, 12 by 5, which is 2.4. Hold on, let me explain the logic, then you will understand. 5, 12 and 13, this is the height. 5 into 12 by 13, 60 by 13, which is 4 point something, which is 4 point something. Can I say that this height value is always less than the sides where the right angle it is formed? I hope it is clear. So R is always less than 6 or 8. R is less than, in fact it is less than the smaller value. R is less than 6. If there is an option 8, eliminate it. In circumradius is always less than the smallest side in a right angled triangle. In a right angled triangle, if it is 5, 60 by 13 is 4 point something. So circumradius is always less than the smallest side of a right angled triangle. This will help us in eliminating some answer options. This will help us in eliminating some answer options. I hope the idea it is clear. In a right angled triangle ABC, this is a right angled triangle ABC. Angle B is nothing but 90 degrees. BN is perpendicular to AC. This is BN. AB it is nothing but 6. If it is nothing but 10, another side that is missing is nothing but 8, which is nothing but 8. What is the value that we require? AN. Already we discussed in our basics introductory things. AN is nothing but 6 square by 10, 36 by 10, 3.6. NC it is nothing but 8 square by 10, which is nothing but 64 by 10, which is nothing but 6.4. So 3.6 and 6.4. 3.6 and 6.4. I hope it is clear. So these is nothing but 4 into 0.9. These is nothing but 1.6. So these is nothing but 9 is to 16. These is nothing but 9 is to 16. These is nothing but 9 is to 16. I hope the idea it is clear. 9 is to 16. 9 is to 16. Next one. Right? In a triangle ABC, angle B is 90 degrees. If this is 90 degrees, ABC, these nothing but 8, these nothing but 15, these BC is nothing but 17 according to Pythagorean triplet. Sin theta is nothing but opposite side by hypotenuse, opposite side by hypotenuse, opposite side by hypotenuse, which is nothing but 8 by 17, which is nothing but 8 by 17. This is nothing but cos C, this is nothing but sin C, this is nothing but tan C, this is nothing but cot C. Right? Sin theta is opposite side by hypotenuse. Sin theta is opposite side by hypotenuse. I hope the idea it is clear. Right? From here onwards we will start with session number 2. In session number 1 we discussed all the key points of right angle triangle properties, and then we tried to execute it in every previous year question of right angled triangle. Right, now see here, in this problem there is a slight mistake which I did it. This is nothing but ABC, this is A, this is B, and it is C. AD is a median and BE is also a median. Two medians AD and BE, two medians intersect. If two medians intersect, if they intersect, then it is called the two medians. If they intersect, then this point G is called the centroid. G is called the centroid. Now see here, if it is a centroid, AG is nothing but 2/3 of AD, which is nothing but 2 by 3 of 9, which is nothing but 6. This is nothing but 6. BG is nothing but 2/3 of BE, which is nothing but 2 by 3 of 12, which is nothing but 8. This is nothing but 8. They both intersect at 90 degrees. So this value is nothing but 10. This value is nothing but 10. I hope the idea it is clear.